Good morning. This is KV Nagbabu, assistant professor in St. Peter's Engineering College. Today we are going to discuss about single phase induction motor. So this is the last topic in the fifth unit. So as we know that we have already learned about the single phase induction motor construction and working principle. So there are four kinds of induction motors are there. One is four types of single phase induction motors. Types are there. These types are single phase induction motors, and repulsion motors, and AC series motor and synchronous motor. And fourth type is synchronous motors. So these induction motors are broadly classified into split phase and in split phase again capacitor start induction motors, capacitor run induction motors, and shaded pole induction motors. These four are in our syllabus: split phase and capacitor start, capacitor run, and shaded pole induction motor. So these four motors are in our syllabus. So first let us discuss about the split phase induction motors. Split phase induction motors means, as we know that the stator and rotor, a single phase induction motor consists of stator and rotor. The stator has single phase winding and the rotor has also has single phase winding. So because of the alternating flux in the stator, and we know that the single phase induction motor is not a self-starting, in order to make this single phase induction motor, and the stator winding is split into two windings, like two windings. The split phase means the winding, stator winding is split up into two kinds of windings. So these two kinds of winding is given like this, and which is consists of two windings. One is main winding and the starting winding or auxiliary winding. Main winding, this is the starting winding, and the starting winding is provided here. So this is the main winding of the stator, and the supply is connected. Single phase AC supply is connected. This is the rotor and this is the. So in split phase, the stator winding is split up into two windings: main winding and the starting winding. Main winding has more inductive reactance, and the starting winding has less inductive reactance and more resistive reactance. So that the current in the stator is dividing something into starting winding and something into main winding. So the total current I is equal to Is plus Im. Im is the current through the main winding, Is is the current through the starting winding or auxiliary winding. This winding is provided for the starting purpose. So in order to convert these alternating flux into rotating flux, these split phase induction motors are split up into two windings. If you see the phasor diagram, taking voltage as the reference axis, and because of having Im is more inductive reactance, so it is approximately 90 degrees to the voltage. So approximately 90 degrees to the voltage. Let us consider that the angle is pi m, and because of having more resistive power, it is approximately close to 0. This is the Is, and the total current is the vectorial sum of Is and Im, the total current. So that the Is and Im will give the resultant current, which gives the load angle delta. So that the torque is directly proportional to sine delta. If delta like this, if delta is more, the torque is more, so that the starting torque is provided by using this starting winding. So here one switch is provided, which is called the centrifugal switch. Once the motor started 70 to 80% of the rated speed and the switch is disconnected, the starting winding is disconnected. Starting winding is disconnected. So these kind of split phase induction motors are used in blowers, fans, and pumps, etc. will be used in split phase induction motor. So in split phase induction motor, as its name indicates, the stator winding is split up into two windings. One is starting winding for the purpose of the starting, and another is main winding for the purpose of the starting of the for the purpose of lagging current in the stator. So here the total current is provided in such a way that the alternating flux in the current is converted into rotating flux, so that the torque will be developed. Okay, so delta is directly proportional to torque. Sin delta is directly proportional to torque, so that the torque, starting torque, will not be at zero. Okay, so next, capacitor start induction motor. Capacitor start induction motor, instead of the inductor, the capacitor is replaced with the inductor. Resistor is replaced, and the remaining thing will be same as that of the split phase induction motor. This is main winding, as we know, and this is starting winding. So this is the capacitor, and the rotor is provided like this, single phase AC supply. Okay, so the instead of the resistance, the capacitor is provided. That is why it is called capacitor. At starting, the switch is closed. Once the motor is started, 70 to 80% of the rated speed, and the switch is disconnected. So like this, the split phase induction motor, the phasor diagram like this, because the current will be split up like this: starting winding, something into starting winding, and the main winding, taking the voltage as the reference axis, and this current is flowing to the capacitor, and the capacitor leads in capacitor current leads the voltage. So that is why the current Is leads voltage by an angle phi s. And similarly, in case of the inductor, pure inductor, it is approximately is equal to 90 degrees. So the current lags the voltage by 90 degrees, and the resultant current is I. So the delta is something small as compared to, so this delta is very small as compared to split phase induction motor. So that is why these capacitor values are small. If the capacitor values are small, starting torque is small. So these kinds of induction motors, capacitor start induction motors, are used for like fans, blowers, etc. So this is for the purpose of the starting only. The capacitor is removed once the motor achieves its maximum 70 to 80% of the speed. Till now we have discussed two kinds of the induction motor, split phase and the capacitor slot. In split phase induction motor, these windings are split up into two windings: starting winding and the main winding. The starting winding is used for the starting purpose, and this is inductive in nature, and this is resistive in nature. That is why it is in phase. Almost Is is in phase with the voltage, and Im is lags voltage by almost 90 degrees, that is phi m, and the resultant current will be provided the delta value, and the delta is the sin delta is directly proportional to torque. And the capacitor start induction motor, in the capacitor start induction motor, this resistance is replaced by the capacitor, so that in capacitor Is leads voltage by an angle pi s. So the total resultant current will not be zero here also, and there is some a small angle, and the small angle means a small torque will be provided, and small torque applications we will use the capacitor start induction motor.